Hi, my name is Mr. Evangelista, and welcome to another episode of Evangelist Science. This lecture is for Tuesday, March 17th. Hopefully everyone is practicing social distancing, and you guys are enjoying being at home, but also taking care of yourself, but also studying hard for your AP exams. Today we are going to talk about parallel circuits. Yesterday we talked about series circuits, so today let's talk about parallel circuits. Alright, let's get right into it. Here we have a parallel circuit. It's got a 9-volt battery, and it's hooked up in parallel to resistor 1, resistor 2, and resistor 3. Resistor 1 has 10 ohms of resistance, resistor 2 is 2 ohms, and resistor 3 is 1 ohm. So to figure out, we're going to have to figure out the total voltage, the total current, and the total equivalent resistance, as well as the voltage drop across each resistor and the current flowing through each resistor. And to do that, the first thing we need is Ohm's law, which remember says voltage equals current times resistance. So if you know 1, you can figure out, if you know 2, you can figure out the other 3. All right, let's figure out what's going on in a parallel circuit. So in a parallel circuit, the current outside of these 3 branches is the same as if you were to add up the currents in each of the branches. Okay, so let me say that again. The current outside the branches, so right before we get to the 3 resistors, is going to be equal to if you add up each of the currents in each of the 3 resistors. Okay? All right, the voltage drop across each resistor is the same, and it's all going to equal the same as the battery in this case. Okay? And it's a little bit different from a series circuit in terms of resistance. It's 1 over the equivalent resistance is going to be equal to 1 over the resistance in resistor 1 plus 1 over the resistance in resistor 2 plus 1 over the resistance in resistor 3. Okay? So let's figure this out. What do we know? We know the battery is 9 volts, and resistor 1 is 10 ohms, resistor 2 is 2 ohms, and resistor 3 is 1 ohm. Okay? So let's figure out the equivalent resistance, or the total resistance, okay? So I do 1 over 10, which is 0.1, plus 1 over 2, which is 0.5, plus 1 over 1, which is 1, and then what does that give me? That gives me 1.6, I believe. Yeah, 1.6. And then now I have to do 1 divided by 1.6 to find the equivalent resistance. And I think that gives me 0.625. See if you can do that math and see if you get the same thing. Okay? Now we have the total voltage, we have the total equivalent resistance. So let's use Ohm's law to figure out the current. Remember, V equals IR, so rearrange a little bit. We get V over R, 9 over 0.625, and that gives us 14.4 amps. Okay? Now, how do we figure out the voltage and the current for each resistor? Remember, it's voltage drop across each resistor and the current flowing through each resistor. Remember earlier we said that the voltage drop across each resistor is the same, and it equals the battery voltage, okay? The reason this is because no matter which resistor an electron goes through, it has to drop the same amount because it's going from one end of the battery to the other. So it has to drop that amount regardless of which resistor it goes through. Okay, so those are all 9 volts. Now we have 2 of our 3 variables. We can use Ohm's law to figure out the third using V over R equals I. So 9 over 10 is 0.9 amps. 9 over 2 is 4.5 amps, and 9 over 1 is 9 amps. Notice that if you add up the current flowing through each resistor, you get the total current. So 0.9 plus 4.5 plus 9 gives us our 14.4 amps. Okay? So again, this is what we were saying earlier, that the current outside the branches is the same as the sum of the currents in the branches.